Imagine for a second reading every single medical journal published in the last century.
Which, would literally take lifetimes.
Right. And then cross-referencing that giant mountain of text with a single patient's incredibly unique DNA profile, and then somehow inventing a brand new, highly targeted cancer treatment all before your morning coffee even gets cold.
Yeah, it sounds completely absurd, like
Yeah.
pure science fiction.
Exactly. But as of today, April 22, 2026, it's rapidly becoming standard practice. I mean,
Yeah.
we are witnessing this monumental shift in what technology is actually capable of doing.
We really are. And it forces us to, well, completely redefine our relationship with our own creations. Because, for the entirety of human history, a tool has been this passive object, right?
Yeah, like a hammer.
Exactly. A hammer just sits inert on a workbench until human momentum swings it. Even a traditional search engine, it just waits blankly for a query. But the systems we're looking at right now, they possess this active generative momentum of their own.
Which is exactly why you're joining us for this deep dive today. Whether you are, prepping to pitch a massive strategic pivot to your board or trying to catch up on an industry that seems to reinvent itself every, Tuesday?
Basically Tuesday, yeah.
Or if you're simply trying to understand the invisible forces shaping your daily life, we are breaking down the core mechanics of this moment. Today, we're unpacking a really comprehensive summary of a technology review piece.
It's a great piece.
It is. It's titled 10 Things That Matter in AI Right Now. And our mission here is to just cut right past the relentless hype cycle. We want to isolate the actual structural trends that are fundamentally altering both our software and our physical world.
Because the fatigue around artificial intelligence is very real right now. The headlines are, they're largely superficial. They focus on the novelty.
Yeah, the shiny new toy aspect.
Exactly. But if you look at the underlying architecture, the actual mathematics and the silicon making it all happen, you start to see that we aren't just dealing with a better autocomplete anymore.
No, not at all.
We are dealing with an entirely new method of industrial and creative production.
Okay, let's unpack this because the very first major takeaway from the technology review piece totally shatters that idea of AI as a novelty act.
It really does.
The explosive evolution of generative AI has moved it way past, generating clever emails or those slowly surreal images with too many fingers.
Right, the six-fingered hands are mostly gone.
Thankfully. Now it's generating wildly complex, multi-layered solutions across massive industries. I mean, we used to think of AI like a really advanced calculator. You put a formula in, you get an answer out.
Right, a straight calculation.
But this sounds like transitioning from a calculator to like a creative coworker who brainstorms a whole project with you.
That's a perfect analogy. And the term generative is doing a lot of heavy lifting there. Initially, we understood generative AI as single modal.
Yes.
You input text, you get text back. Or input text, get an image.
Right.
What the technology review outlines is the shift to multimodal synthesis on a structural level. The system isn't just regurgitating information anymore. It's mapping relationships across vastly different types of data simultaneously.
And the source material gives us this really striking example in healthcare. It describes these generative models actively designing highly personalized treatment plans.
Yes.
So let's ground this for a second. We aren't talking about an AI looking at a list of symptoms and saying, take a standard dose of aspirin.
Far from it. Picture a patient presenting with a really rare cascading autoimmune disorder. Now, a human specialist relies on their education, the recent papers they've managed to
Don't
read.
get time to read them.
Exactly, and their clinical intuition. But the multimodal AI, however, it ingests the patient's real-time blood enzyme levels, their full genomic sequence, and historical medical imaging all at once. And then it maps that specific biological fingerprint against, say, some forgotten oncology trial from 1998. It recognizes a buried chemical correlation that a human researcher they'd never have the lifespan to uncover it.
That's wild.
Yeah.
And let me push back here a bit. If AI is suddenly our partner in innovation, how much of the heavy lifting is it actually doing? Because, synthesis isn't necessarily creativity, is it?
That's a fair question.
It's just advanced pattern matching. Are we, diluting the meaning of innovation by applying it to a machine? If it's just finding a link between a 1998 study and a 2026 blood test, I struggle to call that my coworker. It feels more like I just bought a highly efficient librarian.
Well, what's fascinating here is the sheer scale of the pattern matching. At a certain point, that scale effectively becomes indistinguishable from innovation.
Okay, how so?
So in computer science, we talk about high-dimensional vector spaces. When an AI processes billions of parameters, it doesn't just store facts like a librarian filing books on a shelf. It maps the distance and the relationship between concepts in thousands of dimensions. So when it connects that 1998 oncology trial to the modern autoimmune disorder, it's traversing a conceptual bridge that literally did not exist until the AI calculated it.
Oh, wow.
It is genuinely generating a new hypothesis.
So it's synthesizing a path through an ocean of data that human biology simply doesn't have the working memory to hold all at once.
Exactly. The AI does the heavy lifting of infinite data synthesis, which allows the human doctor to elevate their role entirely. The physician is no longer spending hours just hunting for a diagnosis.
Right, they're evaluating it.
Yes, evaluating a highly sophisticated, custom-generated strategy and applying human judgment to the AI's mathematical intuition.
And the technology review points out that this exact same mechanism is disrupting a completely subjective field too, like entertainment.
Yeah, it's everywhere.
The source specifically highlights AI crafting compelling scripts for blockbuster movies. Now, at first glance, a life-saving medical plan and a summer action movie seem totally unrelated.
You'd think so, but the output is different while the vector space mapping is identical. A blockbuster script isn't just art. It's a highly structured exercise in pacing, tension release, and, demographic engagement.
So an AI isn't just like trying to write witty dialogue. It's cross-referencing decades of audience retention metrics.
Exactly.
It knows that in highly successful action films, the pacing requires a tension spike exactly every, 12 minutes.
Yep, it maps the DNA of a story the exact same way it mapped the patient's genome. It synthesizes the vast historical data of human storytelling and outputs a structural framework.
Right.
A human writer can then take that framework and inject the nuance, the cultural relevance, and their specific voice. It's this active collaboration where the machine handles the structural architecture and the human handles the soul.
Okay. But if we are inviting AI to be a true partner in life and death arenas like healthcare, or, allowing it to shape our culture through entertainment, it immediately forces us to look at the rules governing this partner.
Absolutely. The stakes are incredibly high.
Because you can't just hand over narrative control of our health and our culture to a pattern-matching engine without looking extremely closely at the engine's diet. If this multimodal system is making connections that human beings can't even perceive, we are operating entirely on trust.
Trust that is currently quite fragile, to be honest. And that brings us to the secondary focus of the technology review piece. It addresses the inevitable consequence of relying on these complex generative models.
Right, the ethical dimension.
Yes. When a system is woven so deeply into hospital networks and production studios, the structural integrity of its decision-making becomes the absolute most critical point of failure.
And the source outlines an urgent imperative for responsible AI frameworks. It specifically hammers on the non-negotiable need for active bias mitigation and stringent user privacy.
We have to view these not as abstract philosophical goals, but as rigid engineering constraints. The old move fast and break things era of software development.
Right, the Silicon Valley motto.
Yeah, that is fundamentally incompatible with generative models and high-stakes environments. Because if a photo-sharing app crashes, it's an inconvenience.
Sure.
But if a medical AI hallucinates a correlation based on skewed data, it is catastrophic.
So what does this all mean? Let me play devil's advocate for a second.
Go for it.
We hear these demands for robust ethical guardrails constantly. Companies are being urged to prioritize ethics right alongside technological advancements. But let's be real, doesn't the competitive race to build the smartest, fastest AI usually win out over slowing down to build ethical guardrails?
It's a valid concern.
Right.
Yeah.
Like the pressure to be first to market historically steamrolls the desire to meticulously audit training data for demographic representation.
This raises an important question about the actual mechanics of modern machine learning. Because yes, the temptation to prioritize raw speed over meticulous data curation is immense.
Yeah.
However, within the architecture of these new models, ethics and bias mitigation are no longer just public relations checklists. They are mathematical necessities for the product to even function.
Wait, really? Walk us through that. How is demographic representation a mathematical necessity? Isn't a bias filter just, a layer of code you slap on top of the final product to keep the PR team happy?
No, it cannot be a superficial layer because the bias is baked into the foundational weights of the neural network itself. Let's look back at that healthcare example.
Okay.
Suppose a development team rushes an AI to market to design those personalized treatment plans, and they train it on 50 years of historical medical records.
Which sounds good on paper.
Right, but if those historical records contain systemic flaws, for instance, if the historical data shows that certain minority demographics were routinely underprescribed pain medication due to human bias at the time.
Oh, I see. The AI doesn't know it's looking at human prejudice. It just sees a statistical pattern.
Exactly. It assumes demographic X requires less pain medication. The vector space organizes itself around that flaw. The AI confidently hardcodes that historical prejudice into its mathematical model.
Wow.
So when it generates a personalized treatment plan for a patient today, the output isn't just politically incorrect, it is functionally broken. It generates a treatment plan that actively mismanages pain.
So the raw material is poisoned,
Yeah,
and the highly efficient multimodal synthesis simply accelerates the distribution of that poison.
precisely. The entire value proposition of the AI collapses.
Yeah.
A model trained on skewed data is mathematically defective, and the same structural reality applies to privacy.
Right. Privacy is huge here.
If an AI requires access to your deepest, most intimate genomic data to generate that life-saving cancer treatment, but its architecture cannot guarantee the encryption and siloing of that data, it violates the core regulatory requirements of medical care.
The hospital literally cannot deploy it. So it fundamentally changes the conversation. It's not a matter of a company deciding to, build the AI first and make it responsible later.
Yeah, not anymore.
If the system cannot actively monitor its own weights for historical skew, and if it can't aggressively partition sensitive user data doing its synthesis, it isn't an advanced AI, it's just a massive liability.
Accountability and transparency are the new defining metrics of quality. But, and this is a big but, building a system capable of this level of self-reflection introduces a massive logistical hurdle.
Because demanding that a multi-billion parameter model synthesize the entire history of medical science is computationally demanding enough.
Very demanding.
But if you're simultaneously requiring that same system to run real-time mitigation frameworks and constantly audit its own high-dimensional vector spaces for historical skew, and you run advanced encryption on live genomic data, the math becomes mind-boggling.
It creates an incomprehensible workload. You are demanding that the software not only generate novel connections, but simultaneously evaluate the mathematical integrity of how it arrived at those connections.
Right. And running real-time bias mitigation while synthesizing a billion medical records isn't just a software challenge. It literally melts the architecture of traditional computers.
Literally, yes.
The invisible code is demanding significantly more than the physical world can currently provide. Which brings us to the third crucial reality check from our source material, the physical foundation.
This is the moment where the abstract concepts of high-dimensional vector spaces and mathematical integrity crash headfirst into the hard laws of physics, thermodynamics, and manufacturing.
Because software has officially outgrown its physical boundaries. And the technology review highlights these massive strides in AI hardware, specifically the emergence of entirely new, uniquely tailored chip designs.
Right. For decades, the entire tech industry relied on the CPU, the central processing unit. It was the absolute workhorse of the digital age.
Here's where it gets really interesting. A traditional computer chip, a CPU, is essentially a single, incredibly fast race car on a completely empty highway.
I like that analogy.
If you have a complex mathematical problem, the CPU solves it sequentially. Step 1, then Step 2, then Step 3. It does this at blinding speeds, which is perfectly fine for running a spreadsheet or loading a web page.
But an advanced AI model does not operate sequentially. To map those millions of relationships across texts, images, and genomic data, it requires parallel processing.
Right.
It needs to calculate thousands of probabilities at the exact same millisecond.
So trying to run tomorrow's generative AI on a traditional CPU is like trying to deliver 10,000 packages across a massive city using that one single race car.
It's going to bottleneck.
Exactly. Doesn't matter how fast the car is, it still has to make 10,000 separate trips. The system bottles up. What the AI actually requires is a million slower delivery trucks navigating the complex city grid all at the same time. You don't need a faster car. You need a completely different architecture.
And the technology review notes that this is exactly what is happening with the shift towards specialized AI hardware like neural processing units or NTUs. The silicon is being physically redesigned from the ground up to accommodate parallel processing. They are literally widening the highway to handle the millions of simultaneous calculations required for generative synthesis.
The piece describes this as giving AI a supercharged engine. But it's not just about speed, is it? It's about physical limitations like heat and energy consumption.
Absolutely. A traditional chip running parallel AI workloads draws an absurd amount of power. It generates enough heat to physically damage the silicon.
Wow.
So these new architectural designs are as much about thermal dynamics and energy efficiency as they are about processing speed.
If we connect this to the bigger picture, this hardware evolution is the absolute bottleneck for everything we have discussed. The grand visions of software engineers building bias-free, disease-curing AI are entirely dependent on the physical realities dictated by hardware engineers.
Yes, you cannot execute the personalized healthcare plans without the specialized silicon capable of synthesizing the data instantly. And you cannot run the robust privacy frameworks and mitigation filters without physical chips efficient enough to process those safeguards without drawing more power than a small city.
And you might be listening to this thinking you don't care about the microarchitecture of a piece of silicon or the thermal dynamics of a data center.
Most people don't.
Right. But these hardware advancements are the invisible speed limits on your daily life. They dictate exactly how fast and how effectively these incredible tools will actually reach your laptop, your doctor's office, or your local movie theater.
The software dreams up the solution, but the physical hardware is what actually drags that solution into reality.
It is incredibly rare to see both the software paradigm and the hardware paradigm undergo massive fundamental shifts at the exact same time. But, well, that is the reality of April 2026. Let's pull all this together to see the whole board.
Good idea. We started by analyzing the true nature of generative AI. It has completely transcended the novelty of basic text generation.
No more simple autocompletes.
Exactly. By utilizing multimodal synthesis and mapping high-dimensional vector spaces, it's acting as a genuine partner in innovation. It cross-references data at a scale humans cannot comprehend, generating novel pathways in disciplines as varied as oncology and Hollywood scriptwriting.
We then looked at the rigid, necessary constraints of that immense power. We explored how ethical frameworks, specifically active bias mitigation and data privacy, are not just public relations afterthoughts.
They are structural mathematical necessities. A model trained on skewed historical data generates mathematically defective solutions. Responsibility is now the baseline metric for functionality.
And finally, we grounded those massive software ambitions in the physical world. None of this multimodal synthesis or real-time self-auditing happens without a fundamental revolution in physical hardware.
The shift away from sequential CPUs to specialized parallel processing AI chips is the actual engine driving this societal shift. It's constrained only by the laws of physics and energy consumption.
Staying informed about how these three pillars, the generative software, the mathematical integrity, and the physical silicon interlock, is the only way to genuinely understand the forces shaping the modern world.
It really is. It allows you to look past the daily barrage of tech announcements and see the actual structural foundation being laid down beneath our feet.
But as we wrap up this deep dive, I want to leave you with one final lingering thought to ponder on your own. We just talked extensively about AI generating wildly complex, highly personalized solutions.
Right?
And we talked about the physical hardware evolving to process those solutions faster and faster. But if the silicon continues to scale, and AI eventually exceeds human processing speeds by orders of magnitude,
Which it will.
will there come a day when the bottleneck isn't the technology at all? Like, will the ultimate limitation be our own human capacity to actually absorb, read, and implement the millions of brilliant solutions these systems generate for us every single day?
That is a fascinating dilemma. We are essentially building an engine that produces answers faster than we can even ask the questions.
It really is something to chew on as you navigate the rest of your day. Thank you so much for joining us for this conversation. As always, stay curious, keep questioning the systems around you, and we will catch you next time as we continue to explore the edges of what's possible. Take care.